This video is about solving logarithmic and exponential equations, and it corresponds to section 5.6 of the textbook. Let's begin with a simple example. Here we have log base 2 of 1 minus 2x equals 3. We can take the inverse function of both sides, and that would be taking the exponential of base 2. On the left side, that means we will get the argument of the log function in the line above, 1 minus 2x. On the right side, it means we will now have an exponential of base 2, and what was the right side becomes the exponent. It's now straightforward to solve for x. We simplify the right side of the equation and get 8. And we solve for x. X is equal to minus 7/2. Next, we look at an equation where, again, we'd like to know what x is, and now we have 2 times log base 5 of x is equal to log base 5 of 9. The 2 that the log base 5 of x is multiplied by and put it inside the argument of the log function on the left side of the equation. And now we know that when we have 2 logs of the same with the same base, one on either side of the equation, and they are set equal to each other, this means that their arguments are equal. We can see that x squared must equal 9. The values of x that satisfy this equation are 3 and minus 3. Minus 3 won't work because when we go back to the original equation, we find that that would mean having an argument, an x value, that's negative. And a negative number cannot be an argument for a logarithm. It has to be greater than 0. So that means that the solution to this equation is x is equal to 3. Now let's look at a slightly more complicated equation. Here we have the natural log of x is equal to the natural log of x plus 6 minus the natural log of x minus 4. So the first thing we're going to do is we combine the terms on the right side of the equation and write them in quotient form. Now we have the natural log of the quotient x plus 6 over x minus 4. We have the natural log of something on the left side and the natural equals the natural log of something else on the right side. So this means, again, arguments are equal. So we can extract the arguments and say that they're equal to each other, and that's true. We can multiply both sides of the equation by x minus 4. Use the distributive property to get x squared minus 4x on the left side. And then we can move the terms that are on the right side to the left side, simplify, and we have a quadratic equation. We can factor this equation. And when we do, we find that x can be either 6 or minus 1. But now we have to go back to the original equation and decide whether these values can work or not. Are they acceptable? Can they go into the log functions? For that, when we have a logarithm, its argument has to be positive. So when we look at the term on the left side of the original equation, we see that it's constrained. The value of x is constrained. X has to be greater than 0. Look at the first term on the right side of the equation, we see that x must be greater than minus 6 in order for the argument of that logarithm to be positive. The second term on the right side of the equation, we see that x has to be greater than 4 in order for the argument of that log term to be positive. And overall, x has to be greater than 4. This means that the solution that we found, x equals minus 1, won't work, and we can't include it. And this means, finally, that the only value of x that actually is possible is x is equal to 6. Now let's look at solving exponential equations. Here we have 2 to the x is equal to 5. Now, in the past, we've solved equations like this, except typically we had something like 2 to the x is equal to 16, or 2 to the x is equal to 32, some number that is a power of 2, where it was straightforward to find x. Here, it's less straightforward. It's not as obvious what x is going to be. How will we solve this? Well, we can take the natural log of both sides. And why would we do that? We would do this because the natural log of a number is something we can find with a calculator. So if we'd like to get an exact value or even an approximate value for x, this is a way that we can do it. We take the natural log of 2 to the x on the left and the natural log of 5 on the right. And when we do that, on the left side, we can simplify this, taking the x out of the argument and putting it in front of the natural log of 2 as a factor that it's multiplied by. It's a coefficient. The next thing that we can do is to divide both sides of the equation by the natural log of 2. Leaving x alone on the left side of the equation, which is what we want. If we want to get a numerical value, we can say that x is approximately equal to 2.322, which we can find using either tables or a calculator. Now let's look at another exponential equation. Here we have 5 raised to the x minus 2 is equal to 3 raised to the 3x plus 2. Again, we can take the natural log of both sides. When we do this, we now have the original equation on each side becomes the argument of the natural log. And the exponent in each case can be pulled out of the natural log and put in front as a coefficient. We have x minus 2 times the natural log of 5, and on the right side we have 3x plus 2 times the natural log of 3. We can use the distributive property on both the left and the right, and we obtain x times the natural log of 5 minus 2 times the natural log of 5 equals 3x times the natural log of 3 plus 2 times the natural log of 3. Next, we can take all the terms that have x's in them and put them on the left side of the equation, and all the terms that don't have x's in them and put them on the right side of the equation. This allows us to factor out x on the left side. And we see on the right side that 2 is a common factor. We can factor that out. Divide both sides of the equation by the natural log of 5 minus 3 times the natural log of 3, leaving x alone on the left side of the equation. And then we get an expression which we could simplify with a calculator, or we could just leave like this. Now let's look at a more complicated exponential equation. Here we have 4 raised to the x power minus 2 raised to the x power minus 12 is equal to 0. It sort of looks like a quadratic, which gives us a hint as to how to solve it. So let's look at that first term. We know that 4 can be expressed as 2 raised to the second power. Okay, and then the whole thing is raised to the x power. We know that we can express that same term as 2 raised to the x power squared. And when we do that, we can use a dummy variable, u, where we specify that u is equal to 2 to the x power. So now we can substitute in u, and we have u squared minus u minus 12 is equal to 0. And now it looks like an algebraic quadratic function, polynomial. We can factor this polynomial. We get that u could be either 4 or minus 3 for this equation to be true. But then we have to go back and see if those values will work. It turns out that 2 to the x can't possibly equal minus 3, because when we think about exponential functions, we remember that they can never be negative. So that minus 3 isn't a possible value. 2 to the x could equal 4. And in fact, that would mean that x would equal 2. And that is the only acceptable solution for this equation.